Using data from the pendulum, we conjecture the 18 centimeter pendulum had a frequency of 23 cycles per 100 ticks. 40 centimeter, 16 cycles per 100 ticks. We've explained that. That's fairly straightforward from the number of counts and the number of ticks that I got from one paper. Okay? And the others are going to be similar. These make perfect sense. So I think everybody got something pretty close to those counts. I've rescaled the basic squaring graph once more. Same scale that I used before for the x, but a different scale for the y. The interval from 0 to 4 becomes the interval from 0 to 32. Okay? Now I want to plot one of these points on the graph. Okay? Actually, I'll plot both points on the graph. Let's see how close the points come to this graph. They aren't expected to work all that well, but let's see. Length 18, the count was 23 per 100. So let's see, 16 would go here. So 18 would be about here. So I'm going to say 18, 23. Here's 18, here's 23. It's got a point here. It doesn't fit the graph very well, does it? Okay. And then we've got the point 40, 16. Well, that would, 40 would be up here, and 16 would be about here. Okay? So those points don't fit the graph very well. No reason to expect they would. Try to make it so they would. What I'm going to do now is I'm going to do a graph. Again, of just this part of the, so about like so. Well, we could continue it on, but I'm not going to need another part. And I'm going to take 16 counts at length 40. And I'm just going to take a point on this graph and say that's it. Okay? So this should be so I'm going to say this is 16. You guys, not only say it backwards, I just destroyed important equipment. Okay, let's do it again. 16 counts. I'm putting the length here and the counts here. Okay? Length, counts. I'm going to try to do it right. Okay, so here's 40, and here's 16. Now, if this is 40 and this is 16, well, I've just rescaled the graph again, haven't I? Okay? Don't know exactly what the scale is, but if that's 40, I can subdivide that, get 20, subdivide that, get 10, double this and get 80, and so forth, right? So whether you totally understand that or not, or whether you follow everything I just said, you see that we could rescale the graph. And I'm going to say that if that's 40 and this is 20, I'm going to say 18 is about here. Because if 40 is here, 18 has to be a little more than halfway from 40 to 0, right? Halfway from 40 to 0 is 20. I go just a little further than that. That could be 18. And where's 23? Well, if that's 16, if I subdivide that, I get 8 here. And if I go that much further up here, I get 24. So 1823 would be here. Okay? Well, if this point fits the graph, in other words, if this is part of your graph, this isn't. Okay? And the conclusion is that this squaring function isn't any good for modeling a pendulum. Okay? So, my statement is if one of the pendulum points fits, the other doesn't. So y equals x squared can't model frequency versus length. And one of the big focuses of this course, and one of the main uses for the mathematics you learn in this course, is to model things that happen in the real world. Now, you probably won't have much occasion to model pendulums unless you want to go into manufacturing grandfather clocks or something, but that gets so mathematical you probably won't want to touch it, okay? But there are plenty of things in business and the sciences and the social sciences that do follow mathematical models. And there are plenty of things that can be modeled by the squaring function, especially if we stretch a little bit this way, or move it over a little bit, move it up a little bit. Because you see what we've done here by relabeling, in the first place, we've moved the thing over, haven't we? You know, the axis of symmetry, the axis that goes, the line that goes right through the middle of this thing, is no longer the y-axis. Okay? So we've shifted the graph to the right, and we've kind of stretched things out, or whatever we've done, okay? Now we'll see much more of that. There's some fairly simple rules that you can use to stretch and shift graphs, okay? And there's a way to relate that to the algebra and the formula for the function. Okay, that's a big deal. I'm not going to do that just now, but when you see it, I want you to understand it in this context. Okay? The other thing is, well, squaring function isn't the only function in the world. Okay? There are 5 basic functions. And I'm going to talk briefly about 3 of them. You want to be able to graph those functions using the -2, -1, -1/2, 0, 1/2, 1, 2, okay, for the x values. First, you've got to be able to do the arithmetic. I'm going to talk a little bit about the arithmetic you need to do that. Now, some of those functions would work much better for the pendulum than the squaring function. Okay, we're going to kind of test some of those functions to see how well they might work. Okay.